Hello and welcome back to my Kubernetes series. In the last video we implemented the load balancer. The load balancer allows us to assign an external IP address to a service with the type load balancer. That IP address allows traffic into our cluster. That worked great, but what if you have 10 IP addresses or 20 or 50? Depending on your network infrastructure, that could become a challenge and a nightmare to manage. Looking back at our load balancer implementation, I assigned 10 IPs it manages. So what do we need an ingress controller for? That is a great question. Let's take a look at the nginx-ingress controller website. As per the nginx documentation, an ingress controller lets us configure an HTTP load balancer for apps running in Kubernetes. You can execute content-based routing. But what is that and what does that mean? If you run more than one domain from within your cluster, you can route the traffic to the corresponding service and even have TLS termination for each of these domains with an independent SSL certificate. Why do we need an ingress controller? Let's say you have two domains, example1.com and example2.com. Both websites run in your cluster. Your ingress controller serves as the gateway and upon receiving a request for example1.com, routes the traffic into your cluster to the right service. Upon receiving the request for example2.com, it routes the traffic to another service. Now imagine you have 15 domains or 50. An ingress controller takes care of routing the traffic to the right service in the background, and you can use one external IP address to route traffic to multiple websites or destinations within your cluster. I could potentially get away deploying my services and without implementing an ingress controller. I will have 2 or 3 services for which I would need an external IP, but hey, where's the fun in that? As we now have a little better understanding of what an ingress controller does, let's switch over to the terminal and set one up. If you followed my last videos, you can probably guess what's next. Exactly, we will add a Helm repository and download the values file. To add the Helm repository, we add helm repo add nginx, which is what we call the repository, and then the address https kubernetes.github.io ingress-nginx has been added to your repositories. Helm repo update. The repositories are updated. Helm repo search repo nginx. We get the chart version 4.8 and the app version 1.9. That is the chart we will use to install the nginx-ingress controller in our cluster. Now let's go back into our setup folder, cdk setup. Let's take a look what we have. Okay, last time we implemented metal-lb, and this time we will create a folder for the nginx ingress controller 06. Now we will download the values file, helm show values nginx ingress, and we will output that into the nginx-values.yaml. And if we add the right name, ingress-nginx, we will also get an output. nginx values. Let's now enter into the values file and start customizing it to our needs. Starting on the top of the file, we will not set the name or the full name up here. We'll do that during the installation in the command line. We'll go down, we'll leave everything untouched for now. There will be a few changes which are further down in the file though that we'll have to do. For host port, let's check the ports. They are all active. That's good. Ingress class resource. So the ingress class controller, or rather helm, will create an ingress class resource called nginx, and it's enabled. It's the default which we want. So we'll set this to true. Controller value, that is okay. Ingress class is called nginx, that's good. Publish service, true. Path override scope. Okay, we'll leave that unchanged. Kind. And in here, I want to change this to a daemon set instead of a deployment, which will create 4 pods, 1 on each node. Going further down, I'm not going to change any of those values. Health probes, we'll keep them here as they are. Resources, we'll keep them here as well. No auto scaling, which is fine as well. A daemon set can't be scaled anyway, so that's fine. Only deployments or stateful sets could be scaled. Service, we want the service to be enabled, which is correct. There are load balancer IP. We don't want to set that manually, but we have to set a load balancer class, so the nginx-ingress controller, once deployed, will get an IP address assigned by this load balancer, and that was metal LB. Enable HTTP and HTTPS, so port 80 and port 443 will be enabled. Good, we want that. Families, type load balancer, that's fine. We want to ignore the node ports. Volume mounts, telemetry. Don't care for that too much right now. Cert manager is not implemented yet, so I can't activate it yet. That comes up in the next video. Service monitor, we don't want that either. Prometheus, I don't care. Default backend, sure. What else do we have? Tolerations, affinity, we're not going to assign them to any nodes. We get 4 pods created anyways. RBAC is true, good. Service account is created, and here we go. That's what I was looking for. We'll call this nginx ingress manager. Perfect. And we're at the end of the file, which we will now exit with write and quit. As we have configured the file, we now want to deploy this ingress controller. However, as we want to deploy that in its own namespace, the nginx-ingress namespace, we have to create this namespace first. We do that with kubectl create namespace nginx-ingress kubectl get ns. There is our namespace. Now we can first we're going to say helm search repo nginx. Need the name, the full name of the chart. Helm install nginx ingress the chart dash n into the namespace nginx-ingress dash f nginx-values. Let's execute and see as soon as it's done what happens in the namespace. As usual, when we have such a long output, I want to secure this output, copy it, and paste it into a file so I can come back to that later. Right now, though, I want to say watch kubectl get all dash n nginx-ingress. We see container creating. We see we have an external IP assigned, which is fantastic. And as soon as those containers are running, we can try to reach this external IP in our network. We have our daemon set all up and running. Will take a little longer until we see the 1/1 everywhere. Or the 1 of 1 is ready. Now they are. Let's go now to our browser and have a little look if we can reach the ingress controller. Despite the fact it's telling us it's not found, however, we see it's nginx, and that is our ingress controller. So we can reach the ingress controller and our cluster, at least from within our network. From outside of our network, that is not possible yet. Switching back to our terminal, we can now stop the watch and take a quick look at the output that we got once we deployed the ingress controller. So we see the ingress controller has been installed. We watched it deploy. It may take a few minutes for the load balancer IP to be available. We saw that available as well, and we already tested it. It works. You can watch the status. Okay, we've done that. An example ingress makes use of the controller. So if we look at those details, we see that if we want to deploy an ingress resource, that's how we have to declare it. At first we call the API version, we have the kind ingress, we have the metadata, a name and the namespace for which we deploy this ingress resource. We have the specifications. We call the ingress class name nginx, which we defined earlier. We have rules that are the host name. So for example, the internet address, as soon as a request comes in for www.example.com, then our ingress controller reacts upon this request. HTTP paths, prefix, and there are different prefixes or different path types you can declare. They are all visible on Kubernetes.io. I will leave in the link in the description to check what kind of options you have. We have a backend, the service, and then the name of the service. As soon as the request for www.example.com comes in, the traffic is forwarded to the service example service on port 80. This section is only required if TLS is to be enabled for the ingress, which we will set up, so we will use that as well. Then further down, if TLS is enabled for ingress, a secret containing the certificate and key must also be provided. And we will take a close look at that in the future as well. Now that all of these details are set up and the ingress controller is deployed to our cluster, we can move on to testing if the forwarding of traffic works to different services. To test our ingress controller, I will use a few deployments from the YouTube channel Me and Open Source. Venkat creates great Kubernetes tutorials, and I picked up a few things from watching his videos. One of them was the installation of the NFS provisioner. He also publishes his deployments in his GitHub repository, which I have on your screen right now. As part of his GitHub repository, we can find some deployments to test our ingress controller. Let's now empty our screen and take a quick look at his GitHub repository. In his GitHub repository, we can find 6 files of interest. Starting on the bottom, the nginx-deploy-main, which I used in my previous video for testing metal-LB, and 2 others called nginx-deploy-green and nginx-deploy-blue. These 3 deployments will allow us to verify if our ingress controller works. Additionally, over top, we find 3 ingress resources for each of the deployments. Let's download these files and we'll walk through them in Vim. To obtain the necessary download link, click one of the deployments and click again on raw. Then copy the address and switch back to the terminal, in which we can now enter curl. We should add the option -o and download the first file. Now that we have main downloaded, let's download deploy-green, and we want blue as well. And additionally, we want also the ingress resource 1, 2, and 3. As we downloaded the files, let's start walking through those files quickly and see what each of them does. We'll start with vim nginx-deploy-main. We can see we have a deployment with the labels nginx. It's called nginx-deploy-main. Replicas is 1. And that is already it. Here we have the container nginx and the name nginx. That's pretty much it. So we're going to quit and we're going to enter nginx-deploy-green. So we can see this file is slightly differently. We still have the same thing. We have the labels, we have the replicas, and then there is a volume defined. So we're mounting an external volume into the container. It's called web data. We have an init container. This init container creates a file on the command line, which is called web data index, and in this file we find a bit of text which says I am, and it will be formatted in the color green and the word green. This information is then mounted into our nginx container and will be displayed if we reach that container. As you can imagine, the container blue will be the same thing except for the blue content, and that's what it is. We see the init container creates a file called blue, or rather the file with the content blue, and then mounts it again in the nginx container. So those are our 3 deployments. Now let's go into the ingress resources, vim ingress resource 1. So an ingress resource, as you can see on your screen, is articulated by adding the kind ingress. Then you give the ingress resource a name. As per usual, you can choose any kind of name within a certain specification, obviously, that Kubernetes defines. You have the ingress class name. If you remember back and look back in our video, the ingress class name is nginx that we determined. Then you have rules, and the host name is nginx-example.com. The path is a prefix, and in the backend we are trying to reach the service called nginx-deploy-main, and at a port number 80. Taking a look at our ingress resources, vim ingress resource 2. Oh, that's empty, obviously. As you can see in this file, we have the ingress class name defined, and then we have the rules. And as you can see, you can specify several rules in the same ingress file. So we can see that we have a rule for nginx-example.com, we have a rule for blue.nginx-example.com, and we have a rule for green-nginx-example.com, which means that one file will determine how the ingress controller behaves for 3 different pods, or 3 different targets that we're trying to reach. And as you can see here, we have addresses upon which the ingress controller will react and try to forward to the backend and the service, like for example nginx-deploy-blue. Alright, let's take another look at the ingress resource 3.yaml. And in here, as you can see, this is a different way of specifying how a controller behaves. Where we previously had nginx-example.com, blue-nginx-example.com, and green-nginx-example.com, this ingress resource allows us to specify the nginx-example.com, which means to forward all traffic to the main deployment. Then, if you add a /blue to the host, then you will be able to forward all the traffic to the nginx-deploy-blue, which allows you to define subpaths within your ingress resource. And then last but not least, you are forwarding the traffic to the green pod. As we looked at the files, let's exit and start deploying these resources to our cluster. Let's start with the kubectl. Well, before we do that, let's wait and split our screen again. Having split my screen, I now want to start watching what happens in the default namespace. kubectl get all. Alright, and now we will start deploying our resources into our cluster. We do that by kubectl apply-f nginx-deploy-main will start here, and we can see a container is being created. We will deploy our green container as well as our blue deployment. And you can see all 3 of the deployments are visible, and we have all 3 running. The next step is, as you can see, we have no service, so we need to deploy a service. Otherwise, our ingress resource cannot forward the traffic to our pods because everything has to go through a service. So we expose these deployments by adding kubectl expose. Let's start with the nginx deploy main, and we have to declare a port which we want to expose. We want to expose port 80. nginx. Oh, we want to a deployment. We want to expose a deployment. Okay, that worked, and now you can see a service is created with a port 80, and that's where this deployment is listening, or this service is listening. We now do the same for the green pod, also on port 80, and we do the same for the blue pod. Okay, we have all our services. As you can see, they're all in there invisible. I'm going to empty our screen. Next step is we have to configure our ingress. So let's do that. Vim, and I would like, which one are we going to actually take? Ingress resource. Let's start with ingress resource 1. So as you can see, we have a full address here, nginx-example.com, and we're just going to deploy this ingress resource. We do that with kubectl apply -f ingress resource 1. This ingress resource will not show up on our screen to the right. We will have to find out differently if that was exposed. We do that by kubectl get ing for ingress, and we can see we have a ingress resource 1 deployed. The ingress class is nginx, and our host address that this ingress is listening for is nginx.example.com. In order to navigate to this address, we now need to change settings in our DNS server locally. But what does that mean? Every computer has a so-called hosts file. In this hosts file, you find names of computers and their corresponding IP addresses. If you enter in your Windows File Explorer an address or a name of a computer, this hosts file will translate that to an IP address and then forward the traffic to this specific machine on your network. However, as I'm using Pi-hole for my DNS needs in my network, I will use that Pi-hole to reroute my traffic. So let's switch over to the browser and navigate to my Pi-hole to change those settings. In order to change those, I go to DNS records, and I can now enter nginx.example.com, and I have to provide a corresponding address. In here, I have to provide the address that was given from MetalLB to my ingress controller. As I still remember this address, I can enter it in here. Let's switch back quickly and take a look what address that is. And the address, we can find the address by entering kubectl get all-n nginx-ingress. You will find your IP address right here. This is the IP address that we now have to enter in our configuration for Pi-hole. Once that's entered, click Add. Now the DNS is added, and I can test if my forwarding works. Let's open another tab and say nginx.example.com. And we have successfully rerouted traffic into our cluster through an ingress resource. Let's switch back to our terminal and take another quick look at the other two possibilities and ingress files. ls now vim ingress resource 2. If we now want to forward traffic to the blue pod, we can either declare a complete host path, then we have to repeat the same process. We have to declare the path and the IP address, which is going to be the same. However, we have to declare another address in our Pi-hole, for my case here, or in your hosts file. You have to follow the same process for the green example. That is one option of doing it. However, if I quit and we are going into number 3, instead of declaring an additional or setting up additional DNS records, I can also create this ingress resource and then just add a /blue at the end. That would avoid having to set up another DNS record, or several DNS records for that matter. So I will try to deploy this ingress resource, ingress 3, and take a look at the other two pods and the results we're going to get. So we're going to quit this file, and I'm going to kubectl apply-f ingress resource 3. The result I'm getting is, why are you doing this? You already defined this ingress resource. So we'll kubectl delete-f ingress resource 1, and we're going to deploy ingress resource 3. With this ingress resource now deployed, we can switch back to the browser and hit enter again. We get the screen that we had previously, and if we now add to the back the extension blue, we are forwarded to the blue pod, and we can do the same for the green pod. This test confirms that our ingress controller works. We have deployed 3 different pods, rerouted the traffic through different paths to the 3 different pods, and we can now switch back to our terminal, clean up, and then summarize this video. For the cleanup, we will delete at first the ingress resources, kubectl delete-f ingress resource 3.yaml. We will then clean up the kubectl delete-f nginx deploy-green, deploy-blue, and yeah, that doesn't exist. That's true because it's YAML. And then the main. We also have to delete the services with kubectl delete service nginx deploy blue, green, and main. And our namespace default is back to its default. The last step we would have to do, which I'm not going to show on the screen, we have to delete the DNS entry that I did in Pi-hole, which I'm going to do off screen, but that would be the last step to clean up the deployment we had. With that though, we come to the conclusion of this video. What is working? We have deployed an ingress controller to our cluster that will allow us to manage different domains should we so desire, and reroute traffic to the right service. What is left to do? We have one step in our infrastructure setup remaining, namely the setup of the certificate manager and its related components, which are the certification of a dynamic DNS as well as a certificate replication system, as we want to use said certificate for other purposes on our cluster as well. What's next? Next is the last step in our infrastructure setup by deploying the certificate manager and its components, followed by the deployment of the cool stuff, such as the database, Nextcloud, and an email server. Thank you again so much for watching, and I will see you in the next video.